Well, this is the outline. I speak about a bright introduction about the context, and next is the related work with our proposed, the methods, experiments, and rest. Finally, I talk about the conclusion and future work. Well, the context. This study was developed in the Cusco, in Peru, and using the public transportation system data. This data is from the one company of the transportation. The company is Patron San Jerónimo. Well, for do this work, and we take inspiration about these two papers. Two papers using the LCTN model and LCTN models, and using another data set. The main difference between our approach is that the data set. The data set in these papers, in the previous paper, is for example, the travel time between two bus stops is take a long time. But in the context of Cusco, the time between two bus stops is maybe 1 minute or less. This is the main difference between two studies. Well, for the calculated travel time prediction, it's necessary to take the previous time in between another bus stop. Entonces, to predict the next time predictions, it's necessary and calculate the prediction using the previous time between, well, the previous travel time. Well, this is the close of the time series for three examples. And the main idea for these traits time series is that you can see that exists some patterns, some patterns in this peak. And this information is useful for the training our models, LCTN or COMS LCTN. Well, for predicts the travel time between for some bus stop is necessary calculate using the previous information. But for calculate the time prediction for the first bus stop, it's possible using the concatenate the previous series times. And this image and show this idea. Entonces, for calculate, this is the first bus stop. Let's concatenate the series time prediction. It's possible to calculate the time prediction for the first bus stop. Well, then using the different models, using our data set, it's possible to try LCTN or COMP LCTN's model for time prediction. Since it's possible using these techniques, the intelligent artificial models for calculate the time predictions. And well, about the data set. We recollect the data sets for the Patron San Jerónimo company of transportation. The data set has around 1.6 million GPS points, and each GPS point has, for example, the bus ID, dates, and the times, and speed, navigation, and another information. But for our proposed, the most important data was the data, time, and bus ID. This was the most important feature for our analysis. Well, but we had some problems. For example, for calculate the time between two bus stops, it's necessary uh, finds the GPS point what passing for each bus stop. For example, this is the bus stop points, latitude and longitude, and this is and the green points are the GPS points was generated by the bus, those bus. But for example, for apply our proposal is necessary. It's make a match between some one of these green points with the latitude and longitude of the bus stop. And in some cases, this is no match. Then it's necessary apply the geofencing algorithm for detect the most near GPS points to the bus stop. Well, and after this first approach, we close the points for detect the outlier. For example, here detected this is the previous points plot, and this is the general plot. For example, here exists a multiple outlier, GPS point outlier. And then we do a pre-processing data for cleanse our original data set. It's maybe, and we find another problem. What happened if you had two bus stops, but it no, but between this bus stop no had the travel time. Entonces, for example, for these cases, we propose two cases and one algorithm for the input this missing data, missing time travel between two bus stops. And this is the summary. It's our proposed for input the missing values between, missing travel time between two bus stops.
What is the sampling? Often the bus take a data point.
Sorry.
The sampling frequency. The bus record maybe 30 seconds of each one or 5 minutes. The sampling frequency.
¿Cuál es la frecuencia de tu data?
Okay. And in Cusco, each bus start maybe and each 5 minutes, between 5 and 10 minutes. Yes. Okay. Well, this is the summary of the travel time series. For example, here, and we had, sorry. We had this feature for our data for training our models. And the links, the hour, minutes, and travel time between pair of bus stops. Well, the data set was split in 18%, 80% for the training, 10% for validation, and finally 10% for the test. And this is unsupervised learning. Well, we propose do experiments using 4 models. The first models is the base LCTNs models. These LCTNs models, the principal feature is has a LCTM layers, and sorry, the base LCTM this has a LCTM layers, and the base con LCTM has LCTM layers and com to do layers. It's the main difference between these proposed. Well, for the next models, we had LCTM encoder decoder models. The main difference between these proposed is that here in the LCTM, we had LCTM layers, and here, sorry, and here we have LCTM layers, 4 LCTM layers, 1, this 2, 3, 4, and for next, the difference is that here and happens 4 come to the layers. Well, experiments. Our experiments in beginning was executing in a laptop, in the personal computer. What is doesn't possible because we need more capacity of computational as well, and use the TPU on Google Collaboratory. And for implements, our proposed uses the Python language programming and using these libraries, Keras, TensorFlow, Pandas, NumPy, etc. About the configuration of hyperparameters, we use 3 transfer techniques for transform our data sets: the standard, robust, and min-max scalar, and backside and units 128, optimizer add-ons with 0.001 function activation linear function, and do experiment using this epoch. And finally, the best result was using these 200 epochs. Well, about prediction and test data for multi-state, this is the configurations are similar. And about the metrics, for evaluate our proposed the fourth models, we use these metrics: the root, mean square error, the mean absolute error, and mean absolute percent error. You can see in this picture the loss functions for encoder decoder LCTM and the encoder comp LCTM. And this is the table for our experiment result. You can see in this table that the model that performance better is and according to mean absolute error, is the encoder decoder LCTM using these transformation techniques, standard scalar. Now, the evaluation for multi-time state prediction for the states 1, 5, 10, 15, and 20. And well, and the values highlighted in bold are the best result. Means, for example, here the encoder decoder coincidence has the best performance. Well, according the results, we do experiments for the morning, afternoon, and the evening. This is the result for the afternoon. The blue line is the true values, and the other is the history plots. For example, for base con LCTM, base LCTM, encoder decoder con LCTM, and encoder decoder LCTM. This result is for the morning. This similar result is for the afternoon. This is for the Nike. Well, our conclusions, predictions are made with the 1, 5, 10, 15, 20 time state using an unit state approach. The LCT and encoder-decoder models, according to this metric, the mean absolute error is performing very well comparing to the other models. And the models demonstrate a strong ability to generalize time sequence as a second scale. Well, and future words maybe set out experiments using another variables, for example, the days, week, speeds, holidays, or new routes, and exploring a new different architectures, because we only do experiment using 4 architectures, and or do experiment using another data set, not only on public transportation in Cusco, maybe in another cities, and optimization of road efficiency, considering travel times, it's well, it's another possibility for the future world. Thank you so much for your attention and listening, and I'm sorry for my English.
Really, thank you for the presentation. Anyone have any question, please? Go ahead.
Yeah, thank you for your talk. You start by saying that this problem was studied for other cities around the world. Did you establish any relation with the case of Cusco or any city in Peru?
Please.
Ok. Al inicio, tú has dicho que ese trabajo fue hecho en otros países también. ¿Cuál es la especificidad de Cusco o de Ciudad de Perú?
Ok.
La relación y la especificité.
We find the main difference between the previous study in other countries with Cusco is the data set, because the models are very similar. The models are very similar, maybe, and change some hyperparameters, but it's similar. In Peru, but in Cusco, the data generation is complexity, because in Cusco, for example, there are around 50 companies of public transportation, but only maybe 20, 25 companies of transportation has a device GPS. Another doesn't. Yes, but another difference is that in another countries, the public transportation is good, and they are have a GPS device maybe, and they are generate good data. Just and the travel time between two bus stops is take long time. Maybe about 20 minutes or more, but in Cusco is different. The travel time between two bus stops is very, very few. Yes, sure, maybe, but 1 minute between two bus stops or less. And this is the main.
We are very informal. It's very important.
Yes.
So one car can be here, and the other one is just going to be 30 seconds because they are speeding for competition.
Exactly.
For public competition.
Yes.
It's not a public transportation that you have a car. No, you pay inside the car. So it's
Exactly.
different data set. It's more. I mean, it's more complex. I hear what you were saying. First thing, first error. more money for the driver and for the other person who is in the public transportation. We don't have subways in Cusco. So,
This is important in this kind of work to state all these.
yeah, exactly. These challenges.
Yes.
Es bueno, sería bueno listar en este tipo de trabajos los retos que tienen con esto. La complejidad de los datos, por ejemplo, que hay en Perú.
Okay, thank you.
A real case, and strange case in Peru, but this is what happened. Yeah. Thank you.
Okay, thank you.
Well, thank you. We have our keynote speaker who is outside, but let's go for our coffee break, 10 minutes. And then we're going to have our last keynote speaker. And then we're going to have a small dinner with everyone here. So don't miss that. And a lot of tequila as well. And tea and coffee. Okay, so let's go for our coffee break.
Con la caja del doctor, no,
No.
se la llevo para cargarlo. Sí, acá también.
Okay.
Para que se descargan.